last time there are a lot of last time 104 there are so a lot of people in those sessions here comparing to this time. Not so much, but okay. It's time to start. Okay. Okay. Hello, good morning, everyone. This is DOS working group. I think because it's already 10 o'clock, so we can start our meeting. Okay, welcome. And this is DOS. We are the working group who specify the DDoS open threat signaling protocol. So I think some of you are already familiar with our protocol. Some may be not very familiar, but anyway, we will talk some of our work today and hope you can enjoy this process. Okay, I'm Liang Xia, and my co-chair, Valerie. Yeah, welcome our new co-chair. Yeah. Okay. I'm not sure. Yes, not well. Firstly, this is not well. So I think that many of you have already seen this page in several sessions before. In summary, this page is about the basic rules such as the IPR rules and the conduct rule and how we can contribute to the IETF as a community. So it's very important for every attendee for IETF. So if you haven't read it carefully, so I recommend you to read it. Thank you. And also, and this is a routine work. We need firstly we will pass around our push sheet and please sign it your name. Yeah. And secondly, we need some people to help us to do the JavaScript. So any people can help us. Okay, thank you, Ben. Yeah, and we also need note takers. Okay, thank you, Wei. Thank you. Okay, let's go into our. Okay, this is another one more time. Welcome for Valerie. Yeah, welcome. Yeah. Okay, so let's go into our agenda directory. Okay, so we have more than 10 items today. So I think right now, as a chairs, we will give a very brief introduction of current document status to everyone here and on the meet call remotely. And then we have, I think should be 7 or 8 draft need to discuss this time. And the first one is about using the DOS signaling channel to controlling the filtering rules. So this is a problem that be identified in the DOS POC test interoperability test. So this is a real existing problem. So we have a draft for it, and this is now a working group draft. We will continue to discuss it. And secondly is DOS single channel call mechanism. And the third is about the how to do the server discovery. And then we have the, let me see, this is about DOS mitigation of load use case. This is provided by some vendor, and they have some of their specific consideration of how to do this offload to mitigate the DDoS attack. So they will introduce their use case, and we can see what is their request for the working group. And then we have the we have two drafts from the another operators. One is about the server deployments, and the second is about maybe they want some sort of extension for the current basic DOS signaling channel protocol about the attack type or attack traffic information. Okay, we will see whether we are interested of them. And the last one is really it's a 0.0 draft, but it's a new, but it's not a new draft, a new issue for our DOS working group. Actually, 2 or 3 years. Okay. Oh. Okay. And this about telemetry work. We have discussed this kind of thing before in DOS. But at the very beginning of this working group, we think that maybe it's too early to discuss it for the first stage. But right now, when our basic protocol draft has reached its complete, so some people think that maybe we can raise this issue and to see whether we are still interested to specify this kind of thing, or is it still a problem not clear for us? So we will see based on today's discussion. Okay, and then I think the last, if we have time, we will have a very short discussion and statement about the working group milestone and the charter update to everyone. Okay, that's all of our today's items. So any agenda bashing on these items? Okay, thank you.
So I guess Med was in the Jabber room, but not in the room. I was wondering about the 10-minute slot for the discuss on the cell channel. So if we just remind ourselves which slot that was.
Yes, yeah, you are right. This slide has not updated these items, but we already listed in our web page agenda.
Right.
So we will have this part. Okay. Excellent. Yeah, sorry, it's a little mistake. Okay. We want to give a very short. Yeah, it's already there. I think it's very. What's strange? I don't know why. Let me try this. This is good. Anyway, we'll have the mouse. Okay, quick go through of our current basic protocol draft status. Firstly, congratulations, we have our first working IC. This is about the DOS requirements. This is a very basic document, and we finish its publish. Okay, and then we have our architecture draft. It's already submitted for publication, and I think the IEST is taking care of to give review comments, and we are solving it by our co-authors. Okay, and use case draft is just okay, it's also submitted for publication, and AD is reviewing it. And the signal in China now today they have updated a new version. It's a 36 version, and I think most of the issues has been addressed by a lot of discussion on the main list. If you follow the main list, so I think maybe now it's very near to the final stage to publish this very basic signal in China draft. Okay, maybe later our AD can give more updates, or what I told is enough. Okay, and the similar situation is about the data channel. The data channel is relatively simple to the signal channel, so I think it goes smoothly, and it's also very near the end of the publication status. So we can anticipate it will be published as IMC very soon. Okay, and then in last meeting we have accepted some new working group drafts. They are the multi-homing configuration and the server discovery and the signaling channel co-home and the controlling filtering rules. These are all some extension or some new work about the deployment configuration of the DOS protocol. So we think that they are valuable, so accepted, and we need to discuss during today's meeting and later, and to get more feedbacks for them. Okay, that's all of our current working group draft status. So in summary, they all goes well. Okay. Okay. So I think that's all we want to talk right now, and I think we can go to the presentation. Yeah, presentation time. So first draft is controlling the filtering. Yeah, it's Konami. No. Oh, sorry. Yeah, the missing one. Sorry. Mate, are you online? Hi, mate. Can you hear us? Okay. Yes, this one. Hello, mate. Can you hear us?
Yeah, so Matt, if you're talking, we can't hear you.
Can you join the meet call again, so I can accept you. Come again.
Is it better right now, Frank?
Yeah. It's good.
Okay, so thank you. Yes. So the purpose of this slot is to focus on I would say the only pending issue we have for the signal channel. As you know, that we have many discussions point that we have for the both the signal channel and the data channel. For data channel specification, all the discussed points were resolved, and now we are just ready for Ben to do the last checks on the draft. For the signal channel, we have fixed all the discussed points. There is only one pending point from Miria that we are trying to resolve with the help of the working group, as usual. So in this presentation, there's a lot of slides there, because the intent that I wanted when I designed the slides is that it can be self-contained and someone can understand what is about without having any the voice comment. So if you can go to the next slide, please. Yeah, so this is just a basic, because there was a lot of confusion about the purpose of why we need the herbets at all in the signal channel specification. So there are actually two basic functions. The first one is to assess whether the remote peer is alive or if it is defunct. Because otherwise, if we want to send a mitigation request and the session is broken, we will have all the time to maintain and to mount the session, which induce extra delay, and the mitigation will take a long time. So we need to make sure that once we have the signal channel is established, to maintain it and to assess regularly that the DOTS agent peer is there and the session is working well. And the second objective is really obvious, is that if you have any firewall of any NAT in the path, and these firewalls are just flashing the entries because you are just firing the timeout, we need to make sure that this is there, so that if there's any request back or any notification back from the server can reach with no problem the client. So to do that, we the decision that the design decision that was achieved in the working group is that we just need to send bidirectional herbits between the DOS agent. That means that each DOS peer will send a herbit to the peer, and the other one will just send another herbits for the purposes that are already listed in the slides. So the basic questions there that why we need bidirectional herbits and why not just using the unidirectional herbits would be sufficient. So in the next slide, we are just showing why this is needed. This is just a reminder of I would say, the outcome of the discussion we had on the working group. So if we have to design the herbits as a unidirectional herbits, a first choice we have is that the server has to set the herbits on their sides. But the problem we will have in that case is that if there is no entry in the on-path firewall and path, this herbits won't work, and the behavior will be broken there. So in order to solve the presence of the NATs and the firewalls in the path, we, as shown in the figure below, we need something to fly out from the client to the server first, and then the server will make use this warm NAT entry and the firewall entry so that it can send the herbit. So we need first something to be sent by the client, and then the server to make use of this entry. But then the question became is that if the client is sending the herbits, so why should the server continue to send the herbits in its turn? So this is something that we are explaining right now in the next slide, please, Frank. So now the importance of maintaining both the client and the server herbit is that we have one particular case in the link which is connecting the DOS client domain to the upstream network. So if the client is sending the herbits and there is an outgoing attack, the attack will saturate the link, the incoming link to this client, which means that the client will succeed to send the herbits request to the server, but the server cannot receive any reply from the client. So if the server is receiving the herbits for the client, but it does not receive the response to its own herbits, so this is a clear indication to the server that there is an attack which is ongoing and which is saturating the link to this client, or if there is already a mitigation which is received from the client, that this is an indication that the actual mitigation which is put in place is not effective, and the server will use this information to adjust its behavior. And also, as we show in the next slide, there's also this extreme case, or not extreme case, but another case that if the client fails to send the herbits to the server, and the server cannot receive any herbits from the client, but it does not, in addition to that, does not receive any reply for its own herbits, and it does not receive any traffic from the client, here the server can just initialize the automatic mitigation if this is something which is agreed between the client and the server. So as shown, the design which was adopted by the working group is really something which is aligned with the requirement we have, and this is why we need to have both directions for the herbits from the client and for the server. Next slide, please. And we also have an additional requirement for the signal channel, is that it depends on the time on which we are maintaining the session between the client and the server, whether we have an active mitigation or we are in an idle time. The Dutch agent may decide to adjust the frequency of their herbits messages that they are sending. They may decide even to disable the mechanism when there is no attack, and just to run it when there is attack. So this is really something which is configurable, and something which can be negotiated between the client and the server. And in the specification, the Dutch agents themselves, they manage automatically how they can switch from one configuration to another one based on the attack conditions. Next slide, please.
Hi, Med.
Yes.
This is Ben Kadek. I'm sorry to sort of cut you off. I don't know if we need to go through all of the slides for the entire room. Are they more intended for like Miria and me than the working group directly?
Actually, it's intended to clarify I would say the concern for Miria, but we wanted also to make sure that the working group there is no change, I would say, in the assessment of the working group about the end-to-end functionality and the way we are currently, I would say, handling the current discuss point.
Sure. That's a very good point. Please keep going.
Okay, thanks. So once we go back, we have multiple parameters that are falling under each container of the, I would say, on the configuration. We have the usual co-op transmission parameters and the two additional ones that we are introducing for the sake of the DOTS mechanisms. Next slide, please. So this slide, we introduced it on purpose to address one of the, I would say, one of the comments from Valerie also on the list, but also about the pacing, that comment that was raised by Ben also, is that this is something that is configurable. You can decide just to set, for instance, the missing herbits set to, for instance, the value of 5 and a max transmit of 3. So if there is no loss, the herbits would just be exchanged periodically. But if there is a loss, as it can be showed in the next slide, we will have this backoff that will be used between two herbits, and the same if there is no reply from the peer DOTS agent. So there will be a transmission that will be based on a timeout. That the timeout will be doubled each time there is a failure to receive the reply to the herbits. So this will take at most 45 seconds. And if we have also in the specification said that we cannot send multiple herbits requests if we are waiting for another herbits for which we didn't receive in a reply. And in the next slide, we will show also that this is something which is really flexible, so that you can set, for instance, the max transmit to 1, but you increase the value of your missing herbits, so that you can have a periodicity which is, I would say, you will have more frequent herbits to be sent compared to the previous schema. So it's really deployment specific. And the next slide, please. This one is an example in which we can tweak multiple, I would say, transmission parameters, because we want to optimize the number of the herbits that will be exchanged during a given time span. Next slide, please. So we introduced this modification into the latest version of the I would say the signal channel specification, just to make it clear that we are flexible in terms of, I would say, on configuration. And this is not something which is really frozen. It's up of the DOTS agent to negotiate the appropriate configuration that will be followed during the mitigation time and also the ideal time. And we are accommodating both the periodic one and also the one in which we will send most frequent keep alive requests. Next slide, please. And then we come to this reliable transport. So when we fail, the DOTS agent failed to establish the DOTS connection using the DTLS and UDP. So there's a fallback to use TLS, and in that case, all the retransmission parameters does not apply by default. So next slide, please. We introduce this new clarification to the text as a per request by a comment that we received from Valerie. So for us, this is not a big change into the specification. We are just echoing what we have in the existing RFCs. But in case there are misconfusion or misinterpretation of the text, we are with this new text suggested by to reply to one of the comments we received from Valerie. We make sure that we have explicit text that this does not apply for TCP. So you can, next slide, please. Next one. Next one. So this is one of the core, I would say, discussion points with the Miria is whether we need to use the current co-op existing messages to do the Herbit functionality, or we need to redefine a new one that will be specific to that. So in the current design, we are just using ping pong when TCP is used, and the co-op request for the UDP. Next slide, please. When we declare failure, so when we are using TLS, for instance, this is something that is really under the full control of the DOS agent. It will rely on the timeout of the Pong, which is completely configured by the DOS agent itself, and it's completely up to the DOS application to decide whether it has to give up or it has to continue to wait for a signal from the peer. Next slide, please. So this is for UDP. For UDP, we are just relying on various parameters, the missing heartbeat allowed, but also on the ongoing attack mitigation, and then the server, based on various of this on this criteria, it can decide whether the connection is disconnected or not, and also the client, it will decide when it has to do resumption or not. Next slide, please. So Miria is currently suggesting that we, instead of using the confirmable messages to do the herbits, we should investigate the use of non-confirmable messages to do this functionality. So this will bring us to the next slide, please. So if we want to use non-confirmable messages to do the herbit functionality for the DOS, that means that for the client side, this is no problem, because it's something that we have identified various ways to do that. But the problem is mainly on the server side. So that means that the Dutch server has to send non-confirmable messages. So, in order to do that, we have just to recall some basic that we have in RFC 7252 is that a client is basically something, an entity which sends request, and the server is an entity which receives request. And the only message type that can be exchanged and which is neither a request and a response is an empty message. So if we want the server to initiate Herbert's message, this message needs to be empty ones. But the question is there, is it possible that the server can send on empty, non-confirmable message? So as we can see in the next slide, again, if we go back to RFC 7252, it's explicitly say that a non-confirmable message must not be empty. So we are just looping here, and this alternative approach does not work, because otherwise, the only way it will work is that we have to send confirmable empty messages that we are doing anyway with the co-op request. Next slide, please. So this brings me to, I would say, to the main slide of this presentation, is that we are just here repeating what that the intended functionality we wanted for the Herbert functionality. We just clarified that why there is no alternative approach, and if we want to do an alternative approach, it will violate the RFC 7252, and from that, taking into account this consideration, we would like to have, I would say, a follow-up from the working group, the EDs and the chairs. So how to report back to Miria about this point, so that we can move on.
Thanks, Med. This is Ben Kadek again. Yeah, I think this is actually quite helpful to see all this. I think even coming into this week, we had pretty good understanding for what the case is when we're on reliable transport, and so at least for me in particular, I was just getting a better understanding of the case with the unreliable transport, so the UDP DTLS. And I did get to talk to Maria earlier in the week, and I think that mostly she just wanted to make sure that we were designing something that met the needs that we had, and not just doing something convenient. And so I think it's really good to hear that we've thought about, yes, we do definitely need to have signals initiated from the client and signals initiated from the server, it sort of sounds like we have a less compelling need to get specific responses or acts to the individual heartbeats in each direction, but we definitely need messages initiated in each direction. And given that we know that, we can then go forward and say, okay, co-op doesn't actually let us send the messages from the server that are not confirmable. So that sort of forces our hand, especially because co-op also doesn't let us send the other requests from the server. And so I think that we've done the analysis that we need to do to confirm that the design we ended up at is, in fact, the only design that actually works for this. So I think it should be pretty straightforward to have another conversation with Miria and get the discuss point resolved. So I'm happy to try and find her this week in person and do the explanation, or if you think we just should send her the slide deck and a little bit of an email, we could do that as well.
Thank you, Ben. For me, it's up to you to. I would prefer if the chairs or you can I would say take over for this point, because I have explained I would say many times to Myriad all this, I would say the issues on the design, the intended design, and so on. So I would like that at this time to hand over this to you or the chairs, so that we can resolve to explain a little bit the outcome of the, I would say, of the discussion we had in the working group.
Yeah, definitely. I'm happy to do that.
Thank you.
Because this session, this presentation is out of time, so we must cut the line after the Kanami and the last comments.
Yeah, Kanami Nishizuka. And I'm following the discussion in the mailing list, and there's no objection with this assessment. So thank you so much to John and Med. Then I need to mention that the interoperability testing was only done over co-op over UDP, because my site only uses the co-op over UDP. However, I'm wondering if John could give us some assessment about the co-op over TCP. Yeah.
Yes, I think that's a good suggestion if we can test both cases, and I think that can help us to. Okay, John is coming. Maybe we can. I think.
Internally within my implementation of things, I have done some reasonably extensive test of with the TCP and some heartbeat failures and stuff, but it hasn't been totally rigorous, and it hasn't been with an interop with the likes of Kaname's GoDots implementation. So it's an area for perhaps further testing, but it works. But again, the preferred protocol really is UDP, because we have much better control. We're not reliant on partial link failures or traffic flooding or whatever.
Yes, thank you, John and Kanami. You have done a lot of good work on the interoperability test. And for this typical issue, I still encourage you both to do more tests, because there was some very new update from Med and from signaling trend courses. So if you have any good result conclusions, please send it to an email, and we can get more clear result of this problem. Is that
Sure.
okay? Okay. Sure. Yeah. Thank you. Yeah. I think because of time reason, I think we still have more discussion with AD and the authors of them. So, but anyway, for the time reason, we should go to the next presentation. So it's Kanami. Okay.
Morning, I'm Kaname Nishizuka from Communication. I'd like to present the update of the draft. Better? Good? Yeah.
Okay.
Thank you. Again, I'm Kaname Nishizuka from NTT Communications. I'd like to present the update of the draft control filtering rules using dot signal channel. Then, as Frank mentioned, that this specification in this draft is the outcome of the interrupt testing in the hackathon in IETF 102, then which enables the control of the ACLs of a signal channel in attack time. While the ACLs were installed over a data channel, so it enables the more control on the ACL, so it enhances the capability of the DOTS protocol. Okay, then those functions are already tested in the interrupt testing between I and John. Then I'd like to show the changes since the last IETF block. Then the first one is about the existence of the ACL attributes. Then then when attack is detected, it allows both mitigation requests with and without ACL attributes for the first time mitigation request. So, and also it is clearly noted that it uses the new MID. Then actually our recommendation is to send a mitigation request without ACL attributes first, and then send a request with the ACL for adjusting the scope. The rationale is to avoid delaying the mitigation when an error is encountered due to the ACL processing on the DOT server. So this is the first point. Then second point, we added more details about the behavior of the DOTS agents. If the DOT server doesn't find the ACL name included in the mitigation request from DOT client, then it replies with 4.04 not found error message. Then if the ACL is found, the activation type is updated. Also will be kept as the last state even after the termination of the mitigation request. The lifetime is also updated as if the request was done by data channel. Then, if any failure is encountered to enforce the ACL update, the DOT server returns 5.03 error code with failed ACL updates in the diagnostic payload. Then it is specified that the DOT client must immediately send a new mitigation request without the failed ACL. Okay, then we did updated the for the clarification. Then the draft currently have the 3 examples. In general, when an attack evolves, ACL activity type may be adjusted by a DOT client. For example, the activation of ACL will be done with a new MID. Then also, this is also for the further clarification. The scenario was updated that when an attack is stopped, the DOT client can use the data channel as usual to retrieve the ACLs. Also, this is noted for the further clarification that ACL-related actions are done using DOTS data channel when the attack is no attack is detected. Also, we updated the security considerations. So, what's next? Okay, let me introduce that our Godot, our software, open software implementation, already implemented this function, and there is no problem so far. So we see that no issue is pending and the content is stable. So we'd like to request working group last call here. Thank you so much.
Any comments or questions? As a contributor, I have a question for clarification. Can you go back to the page 2? Can you explain why you need to send the signaling channel mitigation request at the first time with with ACL
Okay. For example, the attack is already happened. Then, if the dot client try to mitigate the DDoS attack, at the same time, enabling it want to enable the already installed ACLs in data channel. So we can enable both ACLs, also mitigation requests.
Okay. Okay. So in your previous document, you haven't mentioned this very corner case. When you send the first mitigate request, you need to activate your ACL right now, right? This is the goal for this modification.
Yeah.
So currently you.
Currently draft clearly allow the both
Okay.
with
Okay.
and without.
Yeah. Okay.
ACL.
Thank you.
Hi, this is Wei Pan from Huawei. Can you turn to page 3?
Yep.
About the last case, if the failure is encountered to enforce the ACL update, I mean, if you send the mitigation request first without the ACL, and then the mitigation will be done, and then you update the mitigation request with the ACL, but the ACL failed. The last sentence, I think maybe not. You don't need to update the request, mitigation request with the without the failed ACL. I think this is not necessary.
Okay. Good point. So this means that the ACL could include the conflict with the other situation. So in order to continue the installing other ACLs, then it should drop the failed ACL. So
I mean here that the ACL is failed, but the mitigation can be done without this ACL. The DOS server can do the mitigation just when it process the failed ACL, it see, oh, it's failed. I omit the ACL. I can do other things, do the rest things. So the DOS client, if you send a new mitigation request just without the failed ACL, it have no new things will happen.
Okay.
I mean,
I got point. Then implicitly the dot client thinks that the mitigation is not sufficient, so it try to install the ACL or deactivate the ACL on the dot server side. So the dot client is it is intended that dot client try to install the ACL. So if the error code was returned, then the dot client carefully change the and check the ACL. Then it will it may or may not install the new ACL.
Yeah, I know that. If the DOS client realize that the one I previously sent is wrong and it failed, that it can't do the update, but with the new one. But if it, the new one is not really necessary. If it doesn't want, can fix the mistake. I mean.
Okay. I will at that point. Then the must seems too strict for that case. So
must is okay, but you need to or must maybe not. I mean, the standard new mitigation request
can we
condition. Yeah.
If we so many detail, can we go on to the main list discussion? So time is not so enough. But there are one more comment from the online Midco.
Yes, so this is just a reply to the comment from Wei. I think that he is right about his observation. So actually, what we are doing is that this immediate new mitigation is only when the ACL is sent in the first mitigation request or in a mitigation with an adjusted mitigation scope. So the text is already, I would say, covering this case. We are not sending immediately a new request. when there is a failure of the if the request or including DSL. It's only for the first one in the if the initial request includes DSL attributes, or if the mitigation includes a new adjusted mitigation scope.
Okay, so as a chair, we think that this document has already we have discussed several rounds, and it's relatively mature, stable now. So so if no any options, maybe I think we will consider raising the working group last call on the main list, and anybody can comment and give your feedback on this. That's okay?
Yep.
Okay. Thank you.
Thank you so much.
Next one. Okay. Next one is about the signal channel call home mechanism.
Hi, this is Wei Pan from Huawei. I present this draft on behalf of the authors because they are not coming today. The update since the Prague about the call home draft. First is the scope. The call home functionality is not specific to home networks, so in this new version, it was be clearly clarified that it applies each time there is a need to filter an attack near the sources, like it will be used for data centers and prices. Text has been added. About the DOS extensions, in the draft, it defined the three new attributes: the source prefix, source port range, and the source ICMP type range. These attributes can be used in the base signal channel, even if the call home functionality is not enabled. The three attributes are optional for the base DOS spec, and when used in the call home functionality, call home scenario, the source prefix is a mandatory attribute, and this is be cleared in the draft. About the next update is about the dedicated heartbeat mechanism. The DOS client retrieve the session configuration parameters from the DOS servers. The DOS server adjusts the heartbeat interval to accommodate binding timers used by on-pass nets and firewalls. The DOS client sends the heartbeat immediately after the receipt of the message from the DOS server to refresh the net and or firewall mappings. If the DOS client detect an outgoing attack, if an outgoing attack saturates the link from DOS server to DOS client, and the DOS client realize that, detect it, so the DOS client must continue to use the signal channel even if no traffic is received from its peer, because it's been saturated. So the DOS message can't be conveyed. If the DOS server receives traffic from the DOS client, the DOS server must continue to use the signal channel even if the missing heartbeat allowed threshold is reached. If the DOS server does not receive any traffic from the peer client, including the replies to its heartbeats, the DOS server must try to resume the DTL session, not to the DTL's client, because the DTL's initiation is reserved in the call home scenario. Next update is
as a contributor, a question for clarification. This dedicated heartbeat mechanism for the call home signal channel, is it different or totally same with the basic signal channel heartbeat mechanism?
It's not really totally different or totally the same. It's some changes because the row is changed in the DOS row of the details row is reversed in this chains, and in the base signal channel, the heartbeat is that how do you say that? Because of the row changed, so the initiator, the process for the DOS server in the base signal channel is suited for the DOS client in the co-home scenario.
But it's only the direction. The other part for the process, I think it should be similar. Should be no difference. Right?
I think so, but maybe matter if you. My opinion, yes, yeah.
Okay, Matt, what's your answer? Oh, please. Can you join again?
Hey, Frank. This is Thiru here. Hello.
Hi, Matt.
Hello. Can you hear me?
Not very clear.
I suggest that we leave this on the main list. Okay, it's not a very big issue. Okay.
Okay. The next update is a request validation. Only immediate mitigation requests are allowed because if you it's not reasonable for the DOS client to send the mitigation request with the trigger mitigation set to false, and it's just our in-case situation for the base signal channel. And for the co-home scenario, the DOS client sends the mitigation must be under the attack during the attack time. So the trigger mitigation can't be sent to false. And the prefix must be validated. Source prefix must be within the scope of the DOS server domain. And by default, the DOS client, the DOS server need to validate the target prefix is under the DOS client's scope. So by default, any routable prefix included in the target prefix is considered as within the scope of DOS client. Some other miscellaneous. First is add some tags about the triggers at the DOS client to initiate co-home requests. And the second is add an appendix to record the design rationale about disambiguating the base signal channel versus co-home signal channel. The third is about to restructure the NAT CGN text. So for the next, there's no issue is pending, and the authors want to request the working group last call.
We think that a little bit polishing is needed for the draft. First of all, I think that the terminology used is a bit confusing because in classic dots we have dot server that is in upstream provider and dot client in your network, and in call home case you use the same terminology, but essentially the server is in a home network and client is a upstream provider. That is a bit confusing for the readers. Probably we need to invent new names to clearly distinguish this case, because classic dots client can be collocated with call home server.
Yeah, I got you.
So I think a few more polishing is needed just for document to be more readable and understandable for implementers.
Yeah, so, I know your point. I think this can be discussed with the authors in the mailing list.
Karamishka, I have the questions about the validation slide.
Which one?
The previous one. Yep. Then, okay, this call home includes two functionalities, I think. Then first one is the role reversal of DTS layer and how to fit mechanism. And the second one is the expansion of source related information. Okay, right? Then I do agree the reversal of DTLS is required, especially if the dot server is behind the NAT. However, this dot call home services is not specific to the home network, so it can be used in the maybe in the provider network, I think. So Hayashi is also making the same use cases. Then, however, in the validation, it only says it should source prefixes should be belong to the dot server domain. However, in the provider's use cases, then the dot server would be closer to the source. However, it not necessary to the closest.
Yep,
to the source.
I got your point.
Yeah.
That I think that the source prefix validation is a mandatory condition for the list here for the co-home scenario and for the base dot signal channel, and this can be considered because of the Yuhei's situation listed there. I think that can be considered later. Yeah.
Yep. I think that is the point. Okay. Second, I have just a question about the carrier grade NAT cases. So if there is an attack from behind the carrier grade NAT, then the attack needs to be mapped from the external IP address to the internal IP address. However, how does client know that the attack source is belonging to which dot server?
Yeah, that's a good question. In the co-home draft, it discussed these situations. But the details, I think maybe Matt will do some clarification.
Yeah, thank you.
Hi, Mimi. Can you hear us? You can say your comments.
Yes. Hello, and I have a question for the call home function. Home function is able to do near attack source mitigation, and I noticed that the most classic scenario is home network. But when you use call home, the source prefix is mandatory, but those attacks are distributed attack. So I think those clients have to send many mitigation requests to the server. Each those server built to different homework. That means that when DOS attack occurs, those clients have to send many parties to the server. Is it another DOS attack?
Sorry, I didn't get your point.
I mean that DOS prefix is hard to aggregate, so they have many source IP, and each source IP may be brought to different homework. So the mitigation requests have to be sent to different server.
I suggest we can discuss in the mailing list.
Okay, I'm very.
Maybe has the answer here. I think we have such discussion before. Okay. See the next comment. Right? Is he or no?
Yeah. So trying to answer the first comment from Kanami, yes, I think that's when the CGN is on the, I would say, on the network side, and the client is also on the network side. We have specified in the document how how it can access to the mapping which are provided by the CGN, so that it can correlate the external IP address and the internal one. And this information can help the DOS client to identify the appropriate DOS server, and then to supply the appropriate information to the appropriate DOS server, so that it can block the attack source which is located in its domain. So we have some discussion in the document to provide not the recommendation on how to do that, but only to provide some examples on how this interface can be implemented at the DOS client. For the validation of the source prefix, what we need is that when there is a client which is contacting a DOS server which claiming that there is an attack which is coming from that network, when the DOS client must make sure that the prefix which is claimed to be a source of attack, it belongs to the domain which is managed by that DOS server. So if you don't have this validation, we'll end up with something which we are just sending, I would say, some requests to some DOS servers who does not have any, I would say, control on on a given IP prefix. So that's why this validation is required for the DOS call home functionality. But when it comes that we will send or we will supply the source prefix as part of the, I would say, the classic the classic signal channel, we don't have this kind of validations.
Kanami, you are still the same issues or new comments?
Yeah, I will try to.
Quick, please be quick.
Yeah,
okay.
Okay. Yeah. Okay. I got that point. So please clarify that in ordinal based signal cases, then the validation will be different from the call home use cases. So in this draft, it is not clear. So it seems it will be applied to the every case. Okay. So.
Okay, let's keep the discussion main list, and maybe we will update the document to clarify some more. Okay. Okay. Next presenter, I think it should be Matt. Okay. About the DOS server discovery. Matt, can you join? You are in?
Yes. Are you displaying the slides?
Yeah, you can start. Sorry.
Okay, thank you, Frank. Okay, so this is an update of the DOS discovery draft. So next slide, please. So this is an update of the I would say what happened recently on the base specification. And by base specification, I meant the DOS signal channel. So this is something we have added to the specification as part of the, I would say, of the ISG review, and especially as part of the discussion about the default port number which is required for the DOS signal channel. So in order to simplify the deployment of the DOS client within home networks and also within enterprise networks, we added an extra, I would say, line into the discovery of the DOS server, saying that if there is no explicit list of IPv4 or IPv6 addresses to contact the DOS server that are provided to the DOS client, the DOS client will try with the default home gateway, the default gateway, whether it embeds a DOS server or a DOS gateway. So the main rationale for that is to simplify the deployment on such network configuration without requiring any software modification at both the host side and also the CPE side, so that it can support this kind of discovery, which can be a barrier for this typical deployment. Next slide, please. We have implemented various changes into the draft. So in the first version that was published just right after the Prague meeting, so we shortened the list of the discovery mechanisms that are supported in the draft, so that to be aligned with the outcome of the Prague meeting we have. And also we included some triggers for executing the discovery procedure. For instance, if there is an expiry of I would say the certificate, we learn a new network and so on, so that we will run again the discovery mechanism, so that we can learn the appropriate Dutch server to be used for a given interface. As part of, and then in the next version, the O2, we have sent a request to the HC working group so that we can ask for a formal review from them. So we received a review from Bernie. So and there was no technical issue about the specification. There is also some, I would say, minor edits that we have implemented in draft. So this is something which is really a good signal to see that, yeah, the current DHCP specification we have on the discovery is really working, and there is no issue with it from the DHC working group perspective. Next slide, please. And in the third version, we updated the discovery to take into account the specifics of the call home context. So we went for a design which is really pragmatic. That means that we are not required to define another new DHCP option for that. We are just using the same DHCP option for both the call home, but also the base signal channel. And we introduced a dedicated service name for the call home itself, with I would say the appropriate text to clarify how this can be used. And the latest version, it was the 04. This one was mainly to address some comments that were raised by Frank. So up to date, so we don't have any pending issue on this on the specification, and all of the comments that we received from the group were implemented on the latest version. Next slide, please. So this is why we do think that we are ready for our working group last call, and the floor is yours.
The chair think that the draft needs a little bit polishing, especially for using normative language in selecting discovery methods. It is not, we're not very happy with this, because, for example, it is written that you should support all three methods, and the should is very close to must, and no text is given when it is acceptable not to support some of the methods. And I think this part of the draft need to be a little bit polished. So.
Yeah, so please, if you have any proposal on this, I would say on this text polishing, so please send on the list and we will discuss it.
Okay. I think we'll discuss it on the list. I'll send a proposal.
Okay, thank you.
Okay, thank you, Matt. I think let's finish this presentation and let's go to our next one. Next one is Yuhei. Yuhei will introduce his operators use cases for how to use DOTS protocol for his for his specific deployment. Okay.
Thank you. I'm Yuhei Hayashi from NTT, draft author of DDoS mitigation fraud, DOTS applicability and deployment. Next, please. This is the agenda.
You may use.
Okay. This is the agenda. First of all, I want to explain goal of my draft. The goal of my draft is to exemplify the use of DOTS in typical deployment context, and I want to assess to what extent current DOTS specification can be applied in particular deployment context and whether there are voids. If there are voids, feedback and update DOTS specification. This is the summary of DMS offload scenario written in my draft. In the scenario, DOTS whose utilization rate is high sends its block traffic information to an orchestrator using DOTS protocol. Then the orchestrator requests forwarding nodes, such as router, to filter the traffic to offload DMS. The scenario is divided into two cases, inbound link case and out-of-band link case. Left one is that the signal between DMS and orchestrator is conveyed via inbound link. On the other hand, right one is signal is conveyed via out-of-band link. And then I explain technical contribution of my draft to working group. One is that I improved DDoS orchestration use case working group draft. The other one is that I check DOTS applicability and describe a deployment consideration of my DMS offload scenario. This is about improvement of DDoS orchestration use case. I added a client function to DMS, and I added summary sentence about DMS offload scenario. In my opinion, it's a minor change. So is it okay to modify the use case working group draft?
You have a question?
Yeah, okay. Question. Sorry.
Okay. Sorry, I just drinking water. So I think we have discussed this point in the main list. So and I, as one of the cause of the use case draft, I have discussed with our leading co-editor, and we tend to agree that you have proposed some new description of the existing use cases. And this is also not a very big change to our currently existing use case. So if our idea permit, I think we can update this use case draft to a new version where just a very little change, and then still can go the next process.
And the question to our ID whether we need a new working group last call because the use case draft already in publication requested state with this update.
Yeah, I mean, I think that the use cases draft is still early enough in the process that we can come back and make some more changes to it. From the process point of view, it probably is worth just doing a quick 1 week. Hey, we added this stuff. Please, now's your last chance to object. Sort of a very short last call.
Yeah, we will do. Okay.
Thank you very much.
Hi, Carmen Shizuka, short comment. So, yeah, I wrote that 3.3 section. Then I'm not okay with the modification to that diagram because it is very confusing. So I will help you to update those text and diagrams with your viewpoint and my point. So then within 1 week, I will do that.
Okay, welcome.
Okay. Thank you. This slide shows about DOTS check applicability and deployment consideration about my scenario. The draft organizes what type of DOTS protocol can be used and what type of information can be conveyed and effective to carry out my scenario. Current DOTS spec is not enough to carry out the scenario, but DOTS spec, including expansion such as a call home draft or filtering control draft, is enough to carry out my scenario. Especially, sending source attribute defined in a call home draft is effective and feasible against reflection attack. It's because abused port of reflection attack is well known, so source port information can be conveyed via inbound link under attack situation, I think. So I think, so I request working group adoption about the deployment consideration part. In my opinion, there are two options, if it's okay. One option is making a new draft about deployment consideration for working group adoption. I'd like to add more scenario to assess what type of extension is needed. The other option is just adding a deployment consideration about sending source information to the core home draft, which is better for working group, or do nothing.
Any comments? Firstly, this is a very relatively new draft, so we want more feedback from the working group, and then we can make decision.
Yeah, first, can you go back to the previous slide? Yeah. In this case, I have some confusing part. Like first, you describe the in-band case, the attack time you divide to two cases, like numbers of reflector is small and enormous. So I'm confused about how to describe, how to distinguish which is small, what kind is enormous, how much can be small. Yeah, and this is the first. And the second is that I noticed that you, in the reflection attack and the non-reflection attack, you have different information to be sent. Like in the left, you send the source port, and in the right, you didn't. So I infer that maybe in the during the non-reflection attack, the source is enormous, and during the reflection attack, then the source is not very much. So also with the destination port, you can see that the destination port is sent in the right side and not sent in the left side. So I infer, well, the many ports will be attacked during the reflection attack, and only a few will be attacked during the non-reflection attack. So this is confusing me because I don't know whether these are real and whether these are true. You can, how do you divide this based on what references you made this conclusion? Yeah. And the third is about the peacetime. The most confusing part is that the destination IP address in charge of one DMS may be a large amount. You only have several DMSs, and they are in charge of the whole traffic of your network. So the desktop IP address, which will be attacked during the attack time, how could you know that in the peacetime? And how could you send it to, if you don't know, how do you send it? I mean, do you know?
Okay. So I want to answer one by one. But sorry, many questions.
maybe I will send it to mailing list, and this I will send it.
Yeah.
Please send it to main list, because I think not only us want to know the answer. Yeah, we want more open discussion.
Yeah,
right? And so many questions, really.
Yeah.
Yeah. Thank you.
Thank you. So I want to clarify to the draft.
So can I ask how many people has read this new draft? Raise your hand. Yeah. Because I think some people in the remotely they already read. It's an interesting draft, and it gives us a new view of how operators use our protocol. I think that's valuable. But this is a very new document, so we cannot make decision right now. We hope that more people can read it and give comments and discuss with you to improve the draft. And about your request about the deployment consideration, I think it may be a choice. It should be useful, but still, it's based on the quality of the draft, right? So we welcome more comments and discussion, and then make decision. Is that okay?
Yeah. Okay, thank you.
Okay,
so
thank you.
I will make the deployment consideration draft. Okay. and I would like to many operators to become co-author, and I want to write this draft. Okay, thanks.
Okay, thank you, Yuhei. Yeah. Okay, Mei-Ling, you are now it's your time. Okay.
Okay, thank you, Chairman. May I ask a question? Ask Yuhei, and then I go on my presentation. Hello.
Okay.
Hello.
Okay, you can continue.
Okay, Yuhei, I'm also interested in your draft. And I agree with your solution, but now I have another way to think about it. Exists any other mechanism to prevent MS for load events in advance, like schedule the MS and allocate amount of medication capacity?
Okay.
I'm Yuhei from NTT, so maybe there's no time, so please send the mailing list to your question, and I will answer it.
Okay.
So I think we have finished his presentation, and for the time reason, we must go to the next presentation. It's from you. So can you start your presentation?
I missed it. Sorry.
It's okay. Yeah.
One.
Yeah. The first one is about your server hierarchy deployment. So please start your presentation.
Okay, thank you. One is a new draft for .7 development. Main purpose of my speech is to attract persons' attention and discuss more on how to deploy .7, and we make some recommendation. Next slide. We all notice that there are several development requirements mentioned in the current draft. When we want to apply those, we have the problem of how do we implement these requirements. Let's have a look of the drafts mention the current content of deployment. Okay, I copied the detailed descriptions to the next slide. We can see that those architectures is those client and the attack packet is expected to be co-located in the same administrative domain, and server and mitigator within the same domain. And in another draft was self-discovery. It is said that a key point in the development of DOS is the ability of network operators to be able to configure DOS client with the current DOS server information consistent, but how to configure client with correct server, it have no more details about it. Next slide. Also in multi-homing draft, it says the DOS client among the server available must select a DOS server whose network has assigned the prefix from which target prefix and target IP addresses are derived. But how to do it? It still have no more information about how to do. So I put up my considerations about it. To meet the deployment requirements, it's necessary to understand the capability of the server. And I also list the related drafts and contents about the server ability. Chairman, next slide. Thank you. In the signal channel, section 4.41, the server must validate the target prefix within the scope of the task kind domain. And in the section 10, it lies the server must verify that requesting task kind are entitled to trigger actions on a given IP prefix. And the exact mechanism for the server to validate that the target prefix are within the scope of the kind domain is format specific. It just say the specific and no more things about it. In the call, I also read call home draft. It's an addition. The task client must validate that attacker prefix are within the scope of the server domain. As other exists the draft mentioned about deployment. Next slide. And next slide. How to satisfy the requirement? We need more through discussions about deployment and functionality, and discuss how to implement it. In my draft, I have to say that my motivation is to provide guidance for operators from my point. We have written about our experiences as an ISP, and we hope that other scenarios will contribute as well. The first have to come into consideration is what kind of equipment can be mitigators. From my experience, they have three kinds of mitigators. First is router. Router can do the black hole to discard all the traffic flow, no matter attack traffic or normal traffic. And the second is special cleaning equipment. This means that it can clean the attack flow and give the normal traffic back to the attack target. And the third kind is network security equipment. I think such as IPS and IDS and firewall or any security equipment. So a question comes to my mind. Does there exist as a single network element? No, I think it should depend on our existing equipment. Next slide. And how to deploy the server? You have to satisfy the conditions. I list the 4 conditions that should be met. The first one is the server to connected with mitigator. For most of the mitigators are internet environments. This means that DOS server can connect with mitigator, but mitigator cannot, maybe cannot connect with DOS server. The second is DOS server can go directly to the mitigator, which had best go through without any other DOS agents, such as DOS gateway. And the third is DOS server has the permissions for scheduling and operations on mitigator. It is because that DOS server rarely decide which one to do the mitigation or do not, and which to do it. And last one is DOS server has the ability to know the address of attack target through to which mitigator. Because I think either correct DOS server to do mitigation will be more efficient. Next slide. We have to put forward two scenarios. The first one is within ISPs, we can solve the attack target. No, we can solve the attack traffic in different ISP with the server installed in the entrance point. For example, if ISP A receive attacks from ISP C, then ISP A asks DOS server C to do the mitigation. Next slide. And another scenario is inside an ISP. I have decided a network for 3 layers: local air network, metropolitan air network, and backbone network. I divide into 3 layers. It is because that we China Mobile divide our network as this architecture. So we think in the entry point of the most important router, like backbone router, main router, and IDC router. We want to install a server, and that's the concept of hierarchical deployment mode. Thank you. So comments and questions are welcome to me.
Hi, Melin. This is Wei Pan from Huawei. I have read the draft. I think it's a reasonable work. It's a good direction for discussion, because you want to deploy the dots, but maybe you encounter some difficulties when you reading the drafts, and you listed them some requirements that you don't know how to fix. I think that is good, because you encounter these difficulties, others may also encounter this, and you listed them out, and we can discuss how to solve them. And this is a first part. I think you can highlight them, and we can have more discussion. And for the 4 conditions you listed that should be met, I think that some are conspicuous, like the first one, DOS server has to interconnect to the mitigator. I think that is it's conspicuous. It's everyone need to do that, or otherwise you cannot connect, you cannot communicate. How could you do the mitigation? And some others, I think that the last one is also a requirements list you listed before in the base signal channel or co-home channel, and I think that you don't need I mean you can't just list the conditions. It's another requirements compared with the base signal channel, and you need to find out discussion or some solutions for these requirements, and your the between ISPs and the inside IP, the diagram, the network top is good, but I don't think it's very clear, because I didn't find where the DOS client in the between the ISPs, and only one DOS client in the inside NSP isn't enough. So I'm also confused. I think it's needed more detailed and maybe more discussion and thought about it. Yeah.
Okay, thank you. Thank you. We really made the program to deploy the DOS deployment. You say that the conditions 1 and the conditions 4 is just another requirement. I agree with you, and maybe we can do more detail and find the solution for this question. And we can discuss more in the email list, and let's contribute together to this direction to fix the problem. Thank you.
Yeah, agree.
Hi, Mei-Ling, Frank, both as a contributor and the chair. I think my personal suggestion is please clarify your request to the working group in how to say it. I also don't see the really requirements for the working group. What we can do what is the problem you are facing? I tend to not see your draft as some red book document to describe how you use the current protocol, but I don't see any problem. I think we have already covered all your problem or your scenario in your document. So maybe you should look at the current protocol more and to describe clearly what is real problem and what is your new use cases, so we can discuss based on them. Okay.
Okay, thank you, Chairman. I will in the next version I will write more detail about the question and the use case.
Okay, and you can continue your next slide.
Thank you. This is my another draft. This draft I will show you our suggestions for attack information carried by mitigation request and mitigation response, vice versa. Next slide, Chairman. Thank you. Let's have an overview. Last meeting in Prague, we came up with 2 draft devices for the goal to add parameter of attack advice to the mitigation request, and another is to add attack type with unified definition. As I see, last presentation I had received the comments that mapping list will slow the progress of different naming of the attack type. I do agree with that, and without any unified definition work, we rarely have a big list for mapping with different vendors. The reason for confused attack type is that Entity DOS project is ahead of the standard development, but it is not a reason to continue the log of attack type definition. And in the architecture draft, it says in the draft that client signal may also include telemetry information about the attack if the DOS client has such information available. In my new draft, I merged the two drafts and added another two parameters. I have to say that our detection system can provide all the information that I added in my draft. Next slide. In this slide, I listed the attack advice and attack type usage for the mitigation and the cooperation mitigation. I have to say that compared with operations, attack type is credible. Of course, operators are not the only one who apply those mechanisms, so we choose it as an optional parameter, not a mandatory. Number of in the case of unliability, we may not use this parameter. From my point, both attack bytewise and attack type will help for DOS mitigation. Attack bytewise have three uses. The first is for current depth selection. Second is for redirection path selection, and last advantage is to offload extreme attack traffic. And the main use of attack type is for mitigation cooperation. Unified attack type will consistent detection type and cleaning interface. Then different vendors can cooperate to mitigate the DDoS attack. And it is important to emphasize that DDoS detection is based on the attack type. Next slide. And this slide will show you three figures about the usage of attack bytewise. The first is for current diverse selection, and the second is for redirection path selection, and the third is for offload extreme attack traffic. If anyone of you interested about it, we can discuss more detail. And next slide. And this slide also shows the attack type, what we can do with attack type. One, we can see that most of the DDoS attack are mixed attack, and different mitigator can do better to muster in for one type of DDoS. So when mixed attack comes, we can select several mitigators for the different attack type. And the second figure is that is to explain that the DOS client receive the attack type and report to DOS server, and the DOS server ask mitigator, hey, help me to do mitigation. And the DOS attack is most likely this attack type. So mitigation can do immediately without any time waste. And last diagram is the recursive with attack type, like put attack type to the DOS server, and DOS client can can get the status of the mitigation. Next slide. We all have noticed that if you have subscribed the mail list, my draft have something in common with Delu's draft. That's the DOS telemetry draft. But the main difference is that we propose for nanny lure. Why we doing this? This is because that we have more than 3 suppliers to provide the DOS screen equipment, and there are many more on the market, and that's just in China. But owning 13% in common of DOS attack name. So that's the motivation we want to do the unified definition. As we see in the table 1, we just have 2 parameters for mandatory and just have three parameters for mandatory, and the other are optional. And the most important I want to show you is the table under. Also, we want to do the attack name complete definition, but we also supply activation definition. It is mean that we no need to transport order base in the link. We can see more capacity of the link. Next slide. And the 2 new parameters I add in my draft is attack source IP number and target tag type shader. It has to say that our DOS detection and warning devices can provide the attack sources, thousands of attack sources. So distribution around the world is hard to aggregate IP addresses. In this scenario, convert IP address with prefix will no help for the mitigation. And the current detection equipment is based on the type of attack errands that are fixed threshold, and the target attack type should will be used to adjust according to the actual situation. And the most important thing is it can help to reduce the false alarms. Next slide.
Hi, Emily. Since we don't have enough time, so we still have one presentation from Tiru. It's very similar like your proposal about the more attack information, more telemetry for the DOS protocol. So I suggest that we go into next presentation directory, and then if we have time, we can have the comments discussion of these 2 drafts. Okay.
Okay, thank you.
So, Tiru, are you there? So it's your time. So sorry for not so many time left for you. So please speed up.
Hey, no problem, Frank. Can you hear me?
Okay. Oh.
Hey, Frank, can
Please
you hear
join
me?
again. Oh, okay.
Hey, can you hear me?
Yes.
Yeah.
Not stable, but yeah.
Okay. Hey, thanks. I think I'll cover this quickly now that we have very less time. Next slide, please. Okay. So to recap, right? I mean, DOS telemetry was presented in IETF 97 by Hood. And at the time, since the DOTS protocol work was incomplete, the decision was to postpone this work and to look into it after the DOTS protocols work is done. Now I see a renewed interest in the working group to pursue this work, so I think it's good to discuss this draft. So as part of the discussion around that time, there was an update to the requirements draft saying that, hey, the client can supply mitigation hints, which could be attack details, and that could be leveraged by the dot server, but they're just going to be treated as hints, and the dot server may even ignore them. What we're trying to do in DOTS telemetry is not just to define the attack description or attack details, but also to convey the normal baseline attributes. And in the next slides, I'll talk about why the normal baseline attributes are useful for DDoS detection and mitigation. And these attributes are just optional, and it's up to the server to decide whether it wants to use it or ignore them. Next slide, please. Okay. The motivation for DOTS telemetry, right? If you see, typically 10 years back, probably most of the traffic baselines were threshold based. But now with more adoption of ML techniques, it's more of anomaly detection based on ML techniques, where you create a baseline, and any deviation from that will be detected by the ML models. Now, this normal traffic baseline would take a few hours to few weeks to baseline and understand for a network infrastructure or for an application what's a normal baseline, especially to deal with flash broadcasts kind of attacks. And that's invaluable information that a DOTS client, which has a DDoS detector or a mitigator, can share with a DOTS server, because the DOTS server, when it's invoked during an attack, it may not have the time to learn and create the normal baseline. The other use case would be that there could be multiple DOTS clients in the victim's network interacting with the DOTS server, and they may not have complete visibility into the attack. But since the DOTS server is receiving the information from all these clients, it would really know what kind of attack, what kind of multi-vector attack, or what kind of target attack that the attacker is using to basically target the victim's infrastructure. The third advantage, because of the feedback that's going to be exchanged between the DOTS client and server, is going to reduce the time for mitigating the attack. So the DOTS server can basically identify the right set of countermeasures, right sets of resources, data centers to mitigate the attack, and it would also help reduce false negatives and false positives. Further, if you see today, many of the DDoS attacks are both multi-vector and mutate, in the sense that they initially target a particular target and then they change the target just to throw the security operations or the automated techniques to get confused or don't have the effective mechanism. So for handling these multi-vector attacks, it's good to share that information so the DOTS server ultimately knows how the attack has been mutating, and to know how it could probably mitigate in the future. So the last point would be that the dot telemetry is not just from the client to server, but also from the server to client, so that the client knows what kind of countermeasures are being used, and for the client to give feedback whether the countermeasures are effective or not. Next slide, please. So the use case for this has to be that the DOTS client network has a DDoS mitigation system or a DDoS detector, which basically is looking at the traffic, baselining the traffic, and doing DDoS mitigation. And when the mitigation exceeds the threshold or the capacity of the on-premise DDoS mitigation system, it requests the DOTS server for help. And that's when all the normal baselining it would have done and the attack traffic it would have seen could be signaled back to the DOTS server as hints, and the DOTS server can use that information to decide the right counter strategy. Next slide, please. So we have defined a bunch of attributes. Based on the discussion in the working group in the last week, I see we want to add a lot more attributes, but this is the initial set, and we are more than willing to discuss and change them. We have categorized the telemetry attributes into 3 sets of categories. One is the pre-mitigation attributes, that is the attributes that will be signaled by the client during peacetime. The assumption is that the client has a DDoS detector or flow collector, which basically is collecting all the traffic telemetry and basically identifying what's a normal behavior or the normal pipe capacity of the the victim's infrastructure. So that gives a good understanding on to the dot server later that this is the normal baseline that the victim's infrastructure typically sees, and anything above that is a deviation from that and can be treated as an anomaly. The second part is Mailing has already covered this to some extent, but this was also this is to basically give more details on the attack that the client is seeing. So it would include the total attack traffic, the total traffic during the attack time, and then various attributes regarding the attack details like the vendor ID, the vendor who the unique INR given ID by the for the security vendor's enterprise number, which detected the attack, and unique local identifier for the attack, and an attack description. We did not go with standardizing the attack because, as we all know, attacks keeps changing, and there is no way that IETF can catch up with new and evolving DDoS attacks. And then we have added an attack severity to basically signal what kind of level of attack severity that the victim's infrastructure is seeing with regard to the DDoS attack. Next slide, please. The second one is going to be again from the client to the server, basically signaling whether the attack was effective or not. In this case, it would signal the total attack traffic it's still seeing even after the mitigation being applied. And if it still sees some attacks still being left out and not detected by the DDoS mitigation system, then it can signal back to the dot server saying that it's still seeing certain type of DDoS attacks which are supposed to be mitigated and not mitigated. So this actually creates a good back and forth communication between the network operation centers in the victim's infrastructure and the security operation center who is dealing with the DDoS mitigation to really see whether their countermeasures are effective or not. Next slide, please. And then the mitigation status would be the dot server can signal back to the client with all the countermeasure mechanisms it's using, all the type of attacks it's seeing, and whether those any subset of these attacks are still continuing or some of the subset of attacks have stopped. This is especially to deal with multi-vector attack or multi-target attack where the layer or the target keeps changing. Next slide, please. So since this is a revival of the draft that was submitted 2 years back, I think we need more comments and discussions in the working group before we decide how to take forward. Any questions?
Hi, Tiru. This is Wei Pan. I have a question that I understand the motivations, and I agree with you, and I support this kind of thing. But I'm doubt about the how to use the telemetry, and I think what's being conveyed in the telemetry is important, but is not the most thing we need to figure out first. And I think the one is that which is the use cases and how to use the telemetry, and if it's suitable to use and under attack, I mean such kind of things, and this should be discussed first. And if we clear about this, the telemetry can be used more properly, and like that. And I also have some.
That makes total sense. What we're trying to do, cover in the draft, to explain the motivation why dot telemetry is required, why those attributes are required, and how they can be consumed. Definitely looking for feedback on if you're feeling short or the description is not sufficient. We can definitely want to improve that.
Yep, I also have some comments about the detail, and I may comments on the mailing list. Yeah.
Sure. Thanks.
Any more comments? Question for clarification? Okay, thank you. This is a very new draft for this stage, so we still need more discussion. It's okay. So thank you too. And I think we finish all our presentation really on time. Yeah, 2 minutes left. But so if anyone has any more thing want to discuss here, we are open. Yeah. If there's not, I think we can finish today's session.
And we have also a topic in agenda to discuss possible changes in the charter. I think we'll discuss it later with our AD because no time today.
And we are also raise a discussion on the main list to let everybody know the latest progress. But I want to say that it's just not a very big change. Just update our milestone and very little change on our charter to include the deployment consideration document in our current charter. That's all. So for your information. Okay, thank you everyone. Thank you for today's joining, and see you in Singapore in next time. Bye bye.
If anybody doesn't sign blue sheet yet, go and sign.